All right, so to prove two things are inverses, we need to like just get your brain in gear here. It's a Monday, and so we're going to just practice a little bit before we teach you how to prove things are inverses. First, you have to be able to stick two functions, like add them together and make a new function out of it. That's one thing that'd be handy to know. So everybody take a look up here and find the f function. That's this one. And then find the h function. That's this one. And is this the kind where they're eating each other? No, this is the kind where we're just adding them. Everybody write down what f plus g is. F plus h, thank you. So here's f, 2x plus 5. Here's h plus, I'll use a new color now for h, x over 2 minus 9. And if I'm going to actually add those together, I know how to do the 5 and the 9, but what if I'm struggling with the other part?
It's minus 1.
Oh, thank you. So let's do negative 5 and 9. Still, I know how to do that part, but I don't know how to do that 2x and the x over 2. What the heck? What do I do?
Well, if you want to add them together, they need to have the same denominator.
So what? Now it has a 2x over a 1 and an x over a 2. How do I get them to have a common denominator?
Well, you could substitute 2x for 4x over 2.
All right. So basically, you're saying I should multiply this one by 2 over 2. And this one by 1 over 1. So that doesn't really need to really multiply by anything. And then this one's x over 2, which is what it was in the first place. And then this one will be 4x over 2. And now you can actually add them together. 4x over 2, the 1x over 2, makes 5x over 2. And these two together, minus 14. Will you have to do that on a test? Yes. In fact, your common denominators will be worse. Let's take a second to talk common denominators. Yes?
Would it be okay if you said 2.5x?
Yes. In this case, I'd be okay with 2.5x. All right, let's also talk about, what do you mean it could be worse, Mr. Server? Let's say that you had this function, 1 over x plus 1, and you added x to that. You can't leave it that way? Nope. You're going to have to get a common denominator to add them together. So let's take a second and practice common denominators. Imagine that's your answer, and you're like, oh, wait, he said we had to actually, like, add them. Get a common denominator, add them together. Well, your first step is, what is the denominator? One's got an easy denominator, x plus 1. Amelia, what's the other one's denominator as it starts? I don't see a denominator, so what do I put there?
1.
Yep. And now, Selena, what's a good common denominator?
X plus 1.
So you really can just leave this one alone, right? And then this one needs to be multiplied by?
X plus 1 over x plus 1.
All right. Now I actually get the final answer. Well, the denominator is x plus 1. What's the numerator, Jack?
The numerator is, I believe, x squared plus x plus 1.
Yeah, x, you're right, x squared plus x. And then this doesn't, it sounded like I implied that was being times. And there's another plus 1 there. And that's it. Now, I was looking to see if the top would factor. Did anybody else look to see if the top would factor? Because if you can factor it, you should, right? But because if it did factor and had an x plus 1 in it, we could have canceled them. But it didn't factor, and so we can't cancel that x plus 1. So there we go. We're done. That's the answer. Be honest, how many of you would have had no problem with that? You're going to be good with that. Okay, good. All right. So I'm going to give you a tougher denominator one now. 2 plus 1 over x plus, let's say, x over 2. Add those all up. Needs a common denominator. So today, I'm getting you ready with all the skills that you will need, the last of them, and then tomorrow review. And then the next day we review a little bit more because we have some juniors. And the juniors on Wednesday are going to be testing, taking the PSAT. And the principal has asked that we not assign anything new on Wednesday. And so we're just do a little bit of review on Wednesday again, and then test is Thursday. We would have tested Wednesday, but out of respect for the principal and his request, I'm pushing it to Thursday. Okay? All right.
So the test is on Thursday.
So the test is on Thursday, yes. All right. Do you agree that the denominator can't just be x? So what do I do? Jack, you answer all the questions. What do you do? Aiden, what'd you do?
I would change the 2 over 1
Wait,
to a...
just tell me what the denominator should be. I gotta know that up front. What denominator should I have at the end?
I'd change them all to 2x.
Nice. We all should have a 2x denominator. You got to think of something that you can multiply everything into. And 2 gets multiplied by something, and x gets multiplied by something, and the 1 gets multiplied by something. So, Aiden, go ahead. You're doing good.
Multiply the furthest left by 2x.
2x,
Top and bottom.
2x. You are correct, sir.
And then the next one just by 2 on the top and bottom. And then the last one by x.
Now, some of you might be thinking about the old days when you had to like multiply by all the same thing. That's if it was an equation. That'd be true if this was an equation, but this is not an equation. As long as you're multiplying each thing by like 2 over 2, which is really equal to 1, that's equal to 1. And this last thing ought to equal 1, x over x, I think you said?
Yep.
Then I now have 4x plus 2 plus x squared, and it's all over 2x. Add it actually all together, x squared plus 4x plus 2 all over 2x. Did anybody look to see if it would factor? Good, that was smart. You should do that. But it doesn't, so yay, we're done. Okay, so that's an example of getting common denominators. You've got to be able to do that. All right, so let's get back to this, and everybody make the h function eat the f of x function. We're doing this problem. I'm highlighting it right here. The h function is going to eat the f of x. It's a composition of functions. What I think you should do is start with the h function. If you're stuck, just start with the h function. And there'd be an x in here, but x is really like an empty parentheses, right? That's the h function. And then what does it eat? An f of x. You can still see it. The f of x is 2x minus 5. Now, would you actually have to add them together? Yes, you would. So get a common denominator and add them together. Amelia, what would be a good common denominator?
2.
So I make this over 1, and then I times it by 2. And then give me your final answer, simplifying the top as you go. Amelia, you got it?
Yeah. 2x minus 5 minus 18 over 2.
And the minus 5 and then minus 18, let's simplify that down.
23.
There we go. Why would it be tragically wrong to say x minus 23? What do you think the kid that does that thinks? The kid who thinks it's just x minus 23. You catch it?
Only the 2x
the kid divided in their head and thought, I can just cancel those off. But the 2x is part of a subtract problem, so that would not be right. All right, you could say 2x over 2 minus 23 over 2, but then you've separated it into two fractions again. That's dumb. We wanted to just have one fraction, so don't do that. Leave this alone. You can't cancel those 2's that are circled. Yes?
Could you simplify it to x minus 23 halves?
I know what you're going to say here, and I'll show people what you did. If you break it into two parts like that, that's okay. And then if you in turn say, I would not want you to leave a fraction though, because then you got two fractions that's supposed to be added together, common denominator and all that stuff. So if you had said this, I'd have been okay with it. What is 23 divided by 2? It's 10, 11, 12, no, 11.5. I would have accepted that. Yes?
Since this time it's like, is it an equation now? So does that mean that you can't multiply things individually?
Can you repeat that?
Since number 2, I think I misheard you, but since number 2 is like an equation, can you still multiply?
Oh, it's not an equation. No, this is not an equation. I know you see an equal sign there, but that's not the same as if this whole thing said like equals 12, then we'd have rules we'd have to follow about doing stuff to both sides and everything. But these are not equations. This is just a problem that they're asking you to figure out. And it's the same exact thing as what's on the other side. So h of f of x is this. This is that. And if they had told us, oh, by the way, set it all equal to 10, then we have to follow the rules of equations. All right, and the last one is finding an inverse. Can you find an inverse? Number 3. There was a 3-step process. I think you were gone, sir, but did you learn how to do it everything for the day you were gone?
Yep, I think so.
So what do you think you're supposed to do on this one?
Substitute y for x.
All right, so I'm going to write the original g of x. Regular g of x is square root of x minus 20. And would you agree we replace the g of x with y? And then what did you say we should do?
Substitute y in for x.
All right, so x equals square root of y minus 20. I'd like to just think of that as swapping. X and y change places. Because that's what happens on a point. If I have a point like 2, 6 on the one problem, 6, 2 will be on the other problem. It switches x and y. All right, can I just stop right there? Charlotte, what do I have to do then?
But you have to add totals.
Nice. Arshawn, I now have x plus 20 equals square root of y. Then I stop?
No.
No. What's the next step? Trying to get y alone.
E squared.
Yes. Now, this is important. Do you get that you can't just square the x and square the 20? You've got to square all of that, which really means x plus 20 times x plus 20. I know some people were thinking, oh, it's just x squared plus 400. Nope. You have to put parentheses around it, because is this the same as just x squared and 20 squared? No, it's not. It's x plus 20 and x plus 20, which makes x squared plus 40x plus 400. There we go. There's our final answer. What's that? That's the inverse. Okay. So what's new for today? What's new for today is that we need to learn how to prove two things are inverses. I say this is its inverse. I say that this and this are inverses. But how do I prove that they're inverses? You can't just say, well, I showed my work. No. There is a theorem that you have to use, and if you can prove that this and this both happen, it's kind of like in a court of law. you have to prove stuff. If in court, you have to prove that you had intent. If this person didn't intend to kill the person, then they can't be considered first degree guilty, of murder. If you can prove you intended to kill this person, then, there's certain levels of proof, right? Well, for math, we have to prove these things are equal by following this certain rule, which is this. If f of g of x, which is where the one function eats the other function, is equal to g of f of x, and they're both equal to x, I'm going to show that this way. I know I could just say equals x at the end, but I kind of like this better. If f of g of x equals g of f of x and they both equal x, then you've proven the two things are inverses. Everybody write that down. This is a thing, a proof you are going to have to use for your last kind of question. And honestly, it's one of the easiest questions once you understand it. You'll like this one. This isn't that bad. You just got to make two compositions. You make it the one eat the other, and then make the other eat the one, and then make sure they simplify down to x. Yes?
If they both equal each other, why do they still have to equal x?
Because they could be equal to each other and not equal to x, and then they won't actually be inverses of each other. So if they end up both coming out to 2, this one simplifies to 2 and that one simplifies to 2, then even though they're the same as each other, they're not inverses. All right, let me just show it to you on a simple one. Would you agree that if I gave you this would be your dream problem to find the inverse for? Y equals x plus 2. You'd be like, oh, it's so easy. In fact, you'd probably think it was a trap. So would you please take a second and find the inverse of that? It won't take you very long. We're going to say this one's f of x. And then what we just found is going to be the inverse of it. Your process should have been like x equals y plus 2. Subtract 2 from both sides. Y equals x minus 2. And that makes sense, doesn't it? These two are inverses. So the inverse was y equals x minus 2. Could I just write f negative 1 of x is x minus 2? Yep. All right. But these are your two functions. I've got them circled here. What do I have to prove again? Well, we set the second one and we just call it g of x. We say, just for the sake of this proof, we're going to call this f of x, which it was, and this g of x, which it technically wasn't, but it was technically the inverse of it. And we're going to see if f eating g comes out to the same thing as g eating x. Would everybody please figure out what is f of g of x? Make the f function eat the g function. And you're going to have to do it just like this. Make a column, and then next to it, show what g of f of x was. Notice you can't go to the right when you solve these. You got to go up and down. Try this. This isn't going to work. It's not going to stick unless you actually do it yourself. F of g of x needs to equal g of f of x. All right. Here's f of x. No, maybe I should even put x plus 2. And then I make an empty spot. And then I make it eat the g of x, which is x minus 2. And look at that. The minus 2 and the plus 2 cancel, and it's just x. Isn't that what I wanted to happen? Yeah. That one equals x. Well, g of f of x is going to look slightly different. Here's the g function. Y equals x minus 2. Then I'm supposed to make it eat the x function. Sorry, the f of x function. So that's x plus 2 goes in here. That's what f of x was. And now it simplifies down to, again, just x. Cool. Did I prove that these came out to the same thing? And that the thing they came out to was x? Yep. There we go. That's how you prove two things are functions. You prove that g of f of x equals f of g of x. And those can be reversed, doesn't matter. As long as you do it both ways. And they both have to simplify to x. So let's try. Any last questions about the process? Do you have to have it in the 2-column thing? Yep. You have to show me, keep it organized, basically. All right. So here's two functions. I think, honestly, that they are inverses of each other. So prove it. And the first thing you write is f of g of x equals g of f of x. And then right underneath that, you keep yourself organized with make it like a T-chart like this. So copy that exactly. And then do the f of g of x on the left, do the g of f of x on the right. And if they don't both simplify down to x, now here's the catch. A lot of people are like, well, duh, this one's going to simplify to x and this one's going to simplify to x. You can't just skip the work? I know they're going to come out to x, but you can't just write the two functions and then say it equals x. You got to show how stuff actually cancels to become x. All right, so here's my f function, and I write 4 empty spot minus 17. Then I make it eat the g of x, which is x minus 17 over 4. Now,
Would it be, okay,
question?
no.
Okay.
I know, wouldn't it be x plus 17? You have to add 17 to both sides too.
Nope. You're thinking these as equations. They're not equations. They're called expressions. All right, so now, making sure, yep. Okay, so now, I could totally see a kid going through and going, yep, the 4's cancel, the 17's cancel, it just comes out to x. What would be wrong with that?
Distribution.
Well, would the 4's cancel? Tell me that much. Would the 4's cancel?
Yeah.
Yes, 4's cancel. Does that actually equal x? No. So then we're done. This actually equals x. We have to say what it is. It equals x plus, minus 34. It doesn't equal x. So these can't be functions. Or sorry, inverses. Yes?
Is the denominator of like x minus 17, is that like 4 or 14? Or?
This was a 4 down here because it ate this. Remember how this one ate that one. That one went in where its x was. And so see, there was a denominator of 4 here and a numerator of 4 there. And so those did cancel each other. But I ended up with x minus 17 minus 17. Do you get that these looked like they were inverses? But they weren't inverses. What one little thing could I have changed and they would have been inverses? Come on.
If you had made that minus 17 a plus 17.
Yep. Either on the one side or the other, either way. If I make this into a plus 17, now these two would have been inverses, but they weren't. Do I have to prove the other side? Nope. As soon as one side doesn't equal x, it's over. All right, on to the next one. All right, get used to this. F of g of x equals g of f of x and a line down the middle to make like a T-chart. You make the one eat the other and the other eat the one. It's either all going to cancel off and they're going to equal x, or it's not. Boy, another problem where the people that are really challenged with algebra can't get this one right. So if that's you, we're gonna have another top 20 on Wednesday. It's just gonna be for practice, but we're gonna see if we can get everybody up to like an 18 out of 20, maybe a 19. If you're a junior, it's just gonna be something you'll do at some point. It's not new material, so I'm following the principal's rules there. And it's not gonna count as a test, so I'm following the rules there. But we'll take another practice. That's what I'm planning to do on Wednesday. Why? Because algebra is so key to this class. All right, just to make sure you're getting this, you should have had 2 empty spot plus 1 over empty spot minus 3. Then you make it eat this in both places. 3x plus 1 over x minus 2 and 3x plus 1 over x minus 2. Get what happened there? Now, oh, I see why he made us learn common denominators. Because you can't just cancel these, can you? You can't cancel that big cluster. The blue stuff, that doesn't just cancel, does it? All right, so what's the denominator of this 1? It's a 1. What do I have to multiply by so that I can get a common denominator up there?
X minus.
X minus 2. And on the bottom, the 3, that's got to be a 3 over 1. And then what do you multiply by there? X minus 2 again. Look at all that. You got to simplify all of that? Yes, you do. And it either comes out to X or it doesn't. All right, I'm going to do the top now. And I have 6x plus 2 plus x minus 2 all over x minus 2. That's this whole top part right here. And then I'll put a red fraction bar. And then I'll do the bottom in blue.
Can I get an example?
Sure. 3x plus 1 minus 3x plus 2 all over x minus 2. Now I got to simplify those down a little bit. The 6x plus the x up here makes 7x. And the 2's cancel. Sweet. Plus 2 and minus 2 are gone. Over x minus 2. Over the 3x and the minus 3x are gone. Yay. And all I have left is 1 plus 2 is 3 over x minus 2. And then if you at this point were stuck, it's because you don't know one of the basics off the top 20. Question first, Jack.
For the, when you're supposed to distribute the, when you're doing the negative 3 over 1 times x minus 2 over x minus 2.
Okay, hold on a second. So are we talking the top of this big fraction?
The denominator.
The denominator of the big fraction. Okay, double checking it now. The 3x and the negative 3x, those will cancel each other out. And the 1 and the, oh, yup, thank you. Right there, I have negative 3x, and I have negative 3 times negative 2 makes positive 6. Good catch. So right there, plus 6. Now, honestly, I would have caught that later. Let me show you why. Let me finish this off. Because I would have been thinking to myself, if this had only been a 7, then everything would have canceled off and I would have gotten X. And I'm going to tell you, on your test, it's actually the easiest if they don't work. And so we don't do that. Do you get what I'm trying to say? Do you get if it fails, you can be like, partway through the problem, you can be like, oh, doesn't come out to X, I'm done. And so we're going to make you do it. And that means I know this answer has to come out to just X. You know what I mean? Like, I can't just say, oh, it fails, no solution. Because that's a big warning sign that, oh, wait a minute. He warned us that it would make us do both sides. And that means they both have to work. Okay, so anyway, you're right. Thank you for catching that. So the 1 plus 6, so that 3 right there is actually a 1 plus 6. That's coming from right here. That and that makes this be a 7 down here. Okay. And now, the top 20 thing that I was about to rant about, I will stop ranting, but bottom line, you have to know what a fraction over a fraction does. And I'm going to keep the top part in blue. 7x over x minus 2, that doesn't change. You flip the bottom one over and you multiply. And then look at that. That cancels that. That cancels that. Answer comes out to x. Sweet. All of that work. But the nice part is, you know it's going to come out to x. It kind of self-corrects itself. Because if it's like, crap, it's not canceling, then you did something wrong. You know you did something wrong. If you didn't catch what I did at the end, it was I took this, flipped it over, and multiplied it. Because that's what you do when you have a fraction over a fraction. Yes?
Now do we have to do that all again?
That's correct. All of that work, and you're only halfway done. Isn't that painful? All right. But honestly, this is at least 2/3 of you are going to get this one right on the test. Because you know that the answer's got to come out to X. And you just got to you'll catch yourself if you're screwing up. Because it'd be too easy if we just make it cancel. Or not cancel, sorry. If we make it come out to something other than X, you'll be on to us and you'll be like, oh, no solution. Those are too easy. All right. All of that, I honestly don't think it's worth it right now in the learning phase to finish that one. I'd rather go to a different one because I think you get the idea and you know it's going to work. We do have the worked out notes for this so that if you want to look at it later, you can. All right, so I actually think this is the part where we should start your homework. There is 3 of them. This is the first one. And you'll find anytime they have 2 separate X's in them, they're a pain in the butt. This is not that hard. This one's not that bad at all. So I think you'll find that you don't mind this one. That was the 15-minute left in class alarm. Step T, how do you start all of these problems?
You do the find the middle, fx equals gx,
F of, tell me exactly what to write, because you do it on every problem.
f of g of x
Yep,
equals g of f of x,
that's correct.
and the line down the equal sign separates the two.
You got it. I don't want it to look like that's a not equal, so I'll start the line underneath the equal sign, but that does equal that. And if you just look quick, it's got a -2, this one's got a +2. This one's got a ×4, this one's got a /4. I think they're gonna work. And we usually don't make them not work. All right, see if you can do this. You need to, there's 3 homework problems. This is one of the 3, okay? So do this one while I'm here. So if you get stuck, you can come up and get help. If you're stuck on the very, very first thing, it's just make F with an empty spot where the X is. And then make it eat the G function. Okay, and that's all I've got for you for today. Tomorrow's review. The next day is a little bit more review, and that's the day that the juniors will be gone. And then Thursday is the test.